command word in this question is evaluate, so you need to come up with an answer. These are non-calculator questions, although some parts of it you might argue maybe you need a calculator. I'll show you some mental math strategies to make it easier. But if it's non-calculator and you know that log solve for exponents, when we look at this initially, we have 9 to what exponent would be 6? We can't do that in our head. We can estimate 0 point something. 9 to what exponent is 72? You're like, oh, it's probably close to 2, but I can't do that in my head. So our strategy is going to be, can we use our log laws? Maybe if we combine this as a single logarithm, we're going to be able to solve it. So I can put the 3 inside as an exponent. And remember that in order to use the subtracting log law, there can be no numbers in front. So now I have one log minus another log. I can combine those together. As log of 6 cubed over 72. So this is the part where you might go, okay, this is difficult mental math. I don't know if I can do that. However, I'm going to teach you some strategies to do this easier with mental math. Instead of multiplying 6 cubed out, even though that's on your powers chart and you know it's 216, 216 divided by 72 might be difficult. Okay? That being said, what we could do is instead of multiplying things out, break it up into its factors. So 6 cubed is 6 times 6 times 6. 72, can you see that 72 is 36 times 2, and 36 is 6 times 6. So 36 times 2, the bottom, you can change to 6 times 6 times 2, and then, very nicely, some of the 6's simplify, and I find this would be a lot easier to simplify than it would be to do 216 divided by 72. So we end up with 3. Now, to solve this, log 9 of 3, because we still need to evaluate and still need to get an answer. Some of you will know the answer. And if you know the answer, you can just do this in your head. 9 to what exponent is 3? If you're able to say half, because you know an exponent of a half is a square root, and square root of 9 is 3, you can write it right away. Okay? But some of you see that when I say it, and would say also, if this was on a test, I wouldn't think that myself. How do I do this? If I can't think of it myself, we'll go back to the technique that we were using before. We're going to say, let x equal log 9 of 3. Then the base is 9, the exponent of x is equal to 3. Look at your powers chart. Are 9 and 3 in the same one? Yes, you can change 9 to 3 squared. So you would get 3 to the 2x is equal to 3 to the 1. So 2x is equal to 1, and x is equal to a half. Yes, that's more work, but if you forgot that a half is a square root and could solve it directly, then you would have to go through this process of solving like we did before. So it's not bad for us to see that. It's a nice review of questions we've done before. For part B, again, none of those logs you can evaluate. So I'm going to start by moving the exponent inside for the 2, the exponent inside for the next one, which will be 3 cubed. Oh, plus log 12. And then when you're adding and subtracting logarithms, remember the shortcut, whatever is added will go in your numerator, whatever is subtracted will go in your denominator. And once again, instead of multiplying this out, because 6 squared times 12, 432, not easy mental math to do, and 3 cubed, 27, not too bad. But then if you had 432 divided by 27, you probably wouldn't like to do that without a calculator. So instead, if we think about the factors here, what do we have? On the bottom, we have 3 times 3 times 3. On the top, we would have 6, which is 3 times 2, 6, which is 3 times 2, and 12, which I'm going to write as 3 times 4. If I write it this way, a bunch of my 3's will simplify. And the mental math is a lot easier. What am I left with? I'm left with log base 4 of 2 times 2 times 4, 16. This one definitely can do in your head. Log solve for exponents. 4 to what exponent is 16? The answer is 2. So circle question number 13.